So, good morning, everyone. Good morning, attorney. Our report is all about the correlation and regression. Introduction. This chapter covers a correlation coefficient and regression analysis, the early part of the diagram and its importance. Then immediately correlation, which is a statistical method used to determine whether a relationship between variables exists. And the second part of the chapter is the regression analysis, which is statistical method used to describe the nature of the relationship between variables that is either positive or negative, linear or nonlinear. There are two types of relationship, which is simple and multiple. In a simple relationship, there are two variables, an independent variable or explanatory variable or predictor variable, and a dependent variable which is response variable. So next. So scatter diagram is a useful tool when checking the assumption in regression analysis. It can be viewed during an initial screening run of the analysis or after the analysis. The benefit of looking at scatter diagram residual is the beginning stages of an analysis is that it may save a researcher time. So if the assumptions are not met, so further screening must be applied before the analysis and it can be completed and data may require cleansing and transformation in case the researcher is not running analysis haphazardly. So in the other term, the scatter diagram pairs of numerical data with one variable on each axis and to look for a relationship between them. So the next is um, person product moment correlation. So person product moment correlation is the most widely used in statistics to measure the degree of the correlation between the linear related variable. The person R correlation would require both variable to normally distributed. So correlation refers to the departure of the random variables from independence. So for example, in the stock market, if we want to measure how two products are related to each other person, our correlation is used to measure the degree of relationship between two products. In statistics, the person correlation, also known as person R, the person product moment correlation coefficient. The correlation or colloquially simply as the correlation coefficient is a measure of linear correlation between two sets of data. So the next page. So this page shows the formula on the person product moment correlation. Next page, please. So correlation coefficient. Person product moment correlation coefficient of simplified correlation coefficients is a measure of linear strength of the association between two variables. So it is founded by Carl Person. The value of the correlation coefficient varies between +1 and -1. When the value of the correlation coefficient lies around +(-1), then it is said to be a perfect degree of association between the two variables, and as the value of the correlation coefficient goes closer to zero, the relationship between two variables must be weaker. This information is summarized in the chart below. So in the next page, so this page shows the chart of the correlation coefficient. So the first one is perfect positive correlation. positive correlation, zero correlation, perfect negative correlation, and nonlinear correlation. So the following summarize the correlation coefficient and strength of relationship. 0.00 is the no correlation, no relationship. Plus minus 0.01 to plus minus 0.20 is a very low correlation, almost negligible relationship. The third one is plus minus 0.21 to plus 0.40 is a slight correlation, definite but small relationship. The fourth one is plus minus 0.41 to plus minus 0.70 moderate correlation or substantial correlation. And the plus minus 0.71 to plus minus 0.90 is a high correlation or marked relationship. The plus minus 0.91 to plus minus 0.90 is a very high correlation, very dependable relationship. And the last one is plus minus 1.00 is a perfect correlation or perfect relationship. So test of significance. A test of significance for the coefficient of correlation may be used to find out if the computed person R could have occurred in a population in which the two variables are related or not. The test statistic follows the t-distribution with 2 degrees of freedom. The significance is computed using the formula of t-test as shown in a formula 10.2. So t equals to r square root of n minus 2 over square root of 1 minus r squared. So next page. So the assumption in person product moment correlation test. Number 1 is a subject are randomly selected. Number 2 is both population are mostly distributed. So procedure for person product moment correlation test. Number 1 is set up the hypothesis. Number 2 is set the level of significance. Number 3 is calculation the degree of freedom. df equals to n minus 2 and determine the critical value of t. Number 4 is calculate the value of person R by using formula 10.1. And the fifth one is state the conclusion. So this was the figure 10.1 testing the hypothesis of correlation coefficient at 0.05 significance level. So when the null hypothesis has been rejected for a specific significant level, there are possible relationship between x and y variables. Number 1 is a direct cause and effect relationship between the two variables. Number 2 is a reverse cause and effect relationship between the two variables. Number 3, the relationship between the two variables may caused by the third variable. Number 4, there may be a complexity of the interrelationship among many variables, and the relationship between two variables may coincidental. So example, the owner of a chain of fruit stores would like to study the correlation between atmospheric temperature and sales during the summer season. A random sample of 12 days is selected with the result given as follows. So step 1 is graph the scatter plot. So step 2 months is a 0.05. Step 4, determine the degree of freedom and the critical values of T. It's referred to table B. And the step 5 is compute for the value of R, our person product moment correlation coefficient. So this picture shows the solution on the problem. The next one is the coefficient of correlation R equals to 0.93 between the atmospheric temperature and total sales indicates a very high positive correlation or very dependable relationship. That is, increase in atmospheric temperature is highly associated with the increase in total sales of fruit shakes. So, diri masunod ang step 6 is the decision rule. In order to make a decision on the significant relationship, we need to determine the value of T. So, gipakita diri ang picture and how to solve the value of T. And the step 7 is the conclusion. Since the null hypothesis has been rejected, we can conclude that there was an evidence that shows significant association between the atmospheric temperature and the total sales of the fruit shakes. And then Spearman-Rank correlation. Spearman-Rank correlation, or Spearman's rule, is a non-parametric test that is used to measure the degree of association between the two variables. Spearman-Rank correlation test does not assume any assumption about the distribution. Spearman-Rank correlation test is used when the version test gives this misleading result. Spearman-Rank correlation was named after Charles Edward Spearman, who developed it, often denoted by P rho or as RS. So in statistics, Spearman's rank correlation coefficient, or Spearman's T, named after Charles Spearman and often denoted by the Greek letter rho as or as RS, is a non-parametric measure of rank correlation. It assesses how well the relationship between the two variables can describe using a monotonic function. Next. Assumptions Spearman-Rank correlation test. Number 1, subject are randomly selected, and number 2 is observation must be at least ordinal level. Procedure for Spearman-Rank correlation test. Number 1 is set up the hypothesis. Number 2, set the level of significance. Number 3, calculation the degree of freedom df equals n2, and determine the critical value of T. Calculate the value of Spearman rho or P by using formula 10-3, and the last one is to state the conclusion. So then in the next page, is the solution, and this one is the steps by steps on how to solve in the Spearman-Rank correlation. So now, step 1, graph the scatter diagram. Step 2, state the hypothesis. Step 3, level the significance is equals 0.05. Number 4, determine the critical region, refer to table B. And step 5, compute the value of P Spearman-Rank order the correlation. So in the next page, you can also see on how to solve the Spearmont-Rank correlation coefficient. Next page is the step 6, decision rule, and then step 7 is the conclusion. And the next topic will be reported by Lay.
So, thank you, Ms. Leslie. Next will be the simple linear regression. So, regression analysis is a simple analytical tool used to model the dependence of a variable on one or more explanatory variables. And simple linear regression is the least estimator of a linear estimation model with a single predictor or one independent variable. Least estimator model determines a regression equation by minimizing the sum of squares of the distances between the actual y and the predicted values of y. So, assumptions of linear regression equation. Linearity. The mean of each error component is zero. Independence of error terms. The errors are independent of each other. Normally distributed error terms. Each error component, random variable, follows an approximate normal distribution. Homoscedasticity. The variance of the error components is the same for each value of the independent variable. Excuse me. So, estimating the coefficient. Formula 10-5 shows you Formula 10-5, 10-6, and 10-7 shows you how to estimate the coefficient. Next will be the sum of squares for error. The least squares method determines the coefficients that minimizes the sum of the square deviation between the points and the line defined by the coefficients. It is called the sum of squares for error or total variations. So, summation, open parenthesis, y sub I subtracted by predicted y sub I close parenthesis square is the variation due to chance denoted by the given, and it is called the unexplained variation. The variation cannot be attributed to the relationship. If the value of r is close to positive 1 or negative 1, then the unexplained variation is small. So next will be the summation of open parenthesis predicted y sub I subtracted by y bar close parenthesis squared is the alternatively the variation obtained from relationship of the given, and it is called the unexplained variation. So opposite rin siya kung sa unexplained variation. Most of the variation can be explained by the relationship. If the value of r is close to positive 1 or negative 1, the better the points fit the line and the closer the explained variation is to unexplained variation. So if all points fall in the regression line, explained variation will be equal to unexplained variation. So figure 10.2 measures of variation in simple linear regression analysis shows you how the different measures of variation in simple linear regression equation. So the formula for the sum of squares is the summation of open parenthesis y sub I subtracted by y bar close parenthesis squared is equal to the summation of open parenthesis predicted y sub I subtracted by y bar close parenthesis squared plus summation of open parenthesis y sub I subtracted by predicted y sub I close parenthesis squared, or SST equals SSR plus SSE. So it is a small standard error of estimate indicates that the independent variable is a good predictor of the dependent variable. Next will be the standard error of estimate. Standard error of estimate is the standard deviation of the observed y values about the predicted y values. The formula for the standard error estimate is as follows. So the formula 10-9 will be the formula for the standard error estimate, where S sub E is equal to the square root of SSE over N subtracted by 2. and is equal to the root of summation of open parenthesis y sub I subtracted by predicted y sub I close parenthesis squared over n2 and sub n minus 2 is equal to the square root of summation of y squared minus b sub 0 open parenthesis summation of y close parenthesis subtracted by b sub 1 open parenthesis summation of x y close parenthesis over n minus 2. So the next will be the coefficient of determination. So the coefficient of determination is the measure of variation of the dependent variable that is explained by the regression line and the independent variable. It is the ratio of the explained variation to the total variation and is denoted by the r squared. Coefficient of determination can also be computed by squaring the value of Pearson's line r squared. So formula 10-10 is the formula for the coefficient of determination, where r squared is equal to the total variation subtracted by unexplained variation divided by total variation, and equal to explained variation over total variation. Or r squared is equal to SSR over SST subtracted by is equal to 1 subtracted by SSE over SST and is equal to 1 subtracted by summation of open parentheses y sub I subtracted by predicted y sub I close parenthesis squared over summation of open parentheses y sub I subtracted by y bar close parenthesis squared. Next will be the confidence interval and prediction interval. Confidence interval represents a closed interval where a certain percentage of the population is likely to lie. So confidence interval. Formula 10-11 is the formula for used to get the confidence interval, and prediction interval is an estimate of an interval in which future observations will fall with a certain probability given what has already been observed. The prediction interval is determined as follows. So formula 10-12 is the formula used on how to get the prediction interval. So next will be the example. Referring to the example involving the atmospheric temperature on sails in page 257, which was discussed by my partner, determine the regressing equation, plot the regression line, and interpret it. Solve for the sum of squares for error, standard error, coefficient of determination. Find the 95% confidence interval of all the temperature with 95 degrees Fahrenheit. Determine a 95% prediction interval with 95 degrees Fahrenheit. So solution. First will be the computation of simple linear regression equation. Step 1 is to obtain the sum of x, y, x squared, y squared, and xy. So as you can see, summation of x, summation of y, summation of x squared, summation of y squared, and summation of xy is already been calculated. So step 2 will be to compute for slope for the simple linear regression. So in step 2, you will use the formula 10-6, which is b sub 1 is equal to n open parenthesis summation of xy close parenthesis subtracted by open parenthesis summation of x close parenthesis open parenthesis summation of y close parenthesis over n summation of x squared subtracted by open parenthesis summation of x close parenthesis squared. So here under that is the calculated method on how to get the slope of the simple linear regression. Next will be the step 3. Step 3 is to compute for the mean value of x and y. So the x bar and y bar will be calculated as follows, will be computed as follows, where x bar is equal to 85.75 and y bar is equal to 176.25. And step 4 is to compute for intercept of the simple linear regression. So b sub 0 is equal to y bar subtracted by b sub 1 multiplied by x bar. So as you can see, it is already calculated where B sub 0 is equal to negative 145.2782. And step 5 is to substitute the slope and intercept the general simple linear regression equation. So predicted y is equal to b sub b sub 1 x plus b sub 0. It is the general equation for simple linear regression, or the formula 10-5. So the simple linear regression is predicted y is equal to 3.7496x subtracted by 145.2782. Next will be step 6. Step 6 is to graph the least square regression line. So in this slide, as you can see, it is already graphed in there, where temperature in Fahrenheit is in the y-axis and the sales is in the x-axis. Thus, the regression equation is predicted y is equal to 3.7496x minus 145.2782. The b sub 1 of 3.7496 indicates that for each additional temperature in Fahrenheit, sales are expected to increase by 3.7496 units. The b sub o value of 1, negative 145.2782 indicates that the intercept with the y-axis is below the origin. A concrete interpretation is that if the temperature in Fahrenheit is 0, a negative 145.2782 units would be sold. Now let's compute for the sum of squares for error, standard error, and coefficient of determination, where you will find the y, the summation of y subtracted by y bar, summation of open parenthesis y subtracted by y bar close parenthesis squared, and the summation of predicted y, summation of y minus predicted y, and summation of y subtracted by predicted y over squared. And as you can see, the total of summation y is equal to 2115, and the next one is 0. The next one is 8118.2500, and the next one is 2115.39, and the next one is 0, and the last one will total to 1141.1406. So next is to find the total sum of squares, where summation of open parenthesis y sub I subtracted by y bar plus parenthesis squared is equal to 8118.25. Kung siya na sa table before. And the summation of squares for error is equal to 1141.1406. And the computation of standard error of estimate will equal to 10.6824, because S of E is equal to 10.6824, and the mean of the independent variable y is equal to 176.25. We would have to admit that the standard error of estimate is small. However, there is no limit on S of E. It is difficult to assess the regression model. In summary, the standard error of estimate cannot be a fixed measure of the regression model utility. Next is to compute the coefficient of determination. So computation of coefficient determination where r squared will, we found that r squared is equal to 0.8594. This statistic denotes that 85.94% of the variation in the fruit shake sales is explained by the variation in the temperature reading the degrees Fahrenheit. So next will be the computation of confidence level. So the first step to compute the confidence level is to determine the estimated value of fruit shake sold when temperature is 95 degrees Fahrenheit, and and the answer will be 210.9338 pound by predicted y is equal to 3.7496x subtracted by 145.2782 will equal to 3.7496 multiplied by 95 subtracted by 145.2782 and will equal to the 210.9338. Step 2 will be the t-value associated with a 95% level of confidence. And step 3 is to determine the degrees of freedom and the critical values of t. Refer to table B. So df is equal to n minus 2 is equal to 12 minus 2 and is equal to 10. And t will equal to positive negative 2.228. So next is to compute the confidence level. So as you can see here, in step 4, the confidence level, it is the computation on how to find the confidence interval. So the level will equal to 198.8975 up to 222.9701. So the number 95% confidence interval for the number of fruit shakes sold when temperature is 95 degrees Fahrenheit is 210.9338 positive negative 12.0363 or 198.9875 fruit shakes up to 222.9701 fruit shakes. Next will be the computation of prediction interval. So in this slide, as you can see, prediction interval is already calculated. This is how prediction interval is calculated. So in the end, prediction interval will equal to 184.2631 up to 237.6045. So we have concluded that the probability is 0.95 and for 95%, and the number of fruit shakes sold is between 184.9631 fruit shakes and 237.6045 fruit shakes. This interval is quite large. And the important distinction between a confidence interval and predicted interval is that confidence interval refers to all cases with a given value of x or independent variable, while a prediction interval refers to a particular case for a given value of x, also an independent interval. So this will be the end of our statistics chapter 10 reporting. Thank you for listening and have a good day.